Hello students. So the last part from this chapter, so what we left with is physical properties and chemical reactions and some uses of water. So first of all, physical properties. What are physical properties? Its physical states, its color, taste, odor, melting points, boiling points, densities, solubilities, all comes under physical properties. So first of all, color, odor, taste. You answer, what is the color of water? It's colorless. What is the taste of water? Tasteless. What is its odor? Odorless. Yes or no? But sometimes water appears in blue color in sea water. Sometimes in some kind of lakes are greenish in color. Sometimes it is pink in color also, like in Australia and in Africa. Why all these colors? These colors are because of the scattering of light, students. And the reason for the pink color and green color is because of the bacteria present in that particular water in that area. For example, cyanobacteria. Some fluorescent bacteria, it can give a glowing light also sometimes. So all these colors are because of the presence of another materials which are growing in water, which are dissolved in water. But real water, normal water, does it have any color? It is colorless. Does it have any taste? Sometimes water has a taste, yes or no? Different areas water tastes different. So we can say water is very nice. Oh, water is not good. Why? This is also because of the dissolved salts present in the water gives a specific taste, but in general water doesn't have taste and it doesn't have any smell, any odor also. Next, boiling point. So what is the boiling point of H2O, students? The boiling point of H2O is 100 degrees Celsius at 1 atmospheric pressure. Yes or no? 1 atm or 76 centimeter of mercury or 760 mm of mercury. That is a pressure condition. Temperature is how much? 100 degree Celsius. That's the boiling point of H2O. Next, what is the melting point or a freezing point? Melting point is 0 degree Celsius. So boiling point is 100 degree Celsius, melting point is 0 degree Celsius. That means below 0 degree H2 exists as ice. After 0 degree it exists as water. Below 100 degree water, above 100 degree vapor. That means below 0 ice, 0 to 100 liquid water, above 100 water vapor. Understood? These are the boiling points and melting points, and these boiling points and melting point changes when if any dissolved salts present in the water. Remember, understood? Normal water is 100 degrees Celsius and 0 degrees Celsius, boiling and melting points. So next, density. What is density? Mass per unit volume is called as density, students. So the maximum density of water is 1 gram per cubic centimeter and it is obtained at 4 degrees Celsius. The density of water increases with increase in the temperature up to 4 degree. In general, students, here some concept is there, listen. So if you increase the temperature, water molecules gains the temperature and they expand. If they expand, the number of molecules per water increases or decreases. Water molecules are expanding. At that space, number of molecules are more or less? Less. If molecules are less, the density should be less, yes or no? That is correct. The concept is correct. But what is happening for H2O between 0 to 4 degree? This is specially happening only for water between 0 to 4 degrees Celsius only. If you are increasing the temperature, that means 0 to 1, 1 to 2 degree, 2 to 3, 3 to 4, the molecules are contracting, coming closer. That's why density is increasing. This property is called as anomalous behavior of water. This is because of hydrogen bonding that we'll discuss in the coming classes, students. So that's the reason why it shows this anomalous behavior only this temperature. From 4 degree, again, if by increasing the temperature 5 degree, 6 degree, 7 degree, the density decreases. Got the clarity? This is only happening between 0 to 4 degrees Celsius. At 4 degree, it has maximum density. So conductivity. Conductivity means electricity. Does pure water conduct electricity? Pure water is a bad conductor of heat and electricity. The conductivity of water is due to the presence of dissolved salts in water. That means distilled water, only water, H2O. Does it conduct electricity? The answer is, students, no, it doesn't conduct electricity because of the absence of free ions. Yes or no? So it doesn't conduct electricity. So which water conducts electricity? Tap water, potable water. It contains dissolved minerals, calcium ions, sodium ions, chlorides. These ions are the carriers of electricity and because of that reason they conduct electricity. So normal distilled water, bad conductor. Drinking water, tap water, potable water, good conductor of electricity, right? So next we have specific heat capacity. Specific heat capacity means the amount of energy required to increase the temperature to 1 degree. What is that? What is specific heat capacity? The amount of heat energy required to raise the temperature of a unit mass of a substance through 1 degree centigrade or 1 Kelvin. That is called as specific heat capacity. I'll explain clearly, students listen. Sir, what is this? Why heat is required to increase the temperature? If you provide 1 degree, why it is not getting 1 degree? The reason is, students, this heat energy is gained by the molecule. Understood? This heat energy is initially gained by the molecule. So all the molecules, first of all, this energy is segregated. For that it requires some energy or not. Then the temperature levels rises. So how much energy is required to raise the temperature is called as specific heat capacity. And water has one of the highest specific heat capacity, students, almost around 1 calorie per gram or 4.2 joules per gram. Water has the highest specific heat capacity among all the substances. The temperature required to raise the temperature of that unit mass of a substance. Next, latent heat of vaporization. Students, it is the heat energy required to change a particular amount of water at 100 degrees Celsius into steam. So why heat energy is required to change water into steam? Why? Because at 100 degree it is changing, students. So if directly maintain 100 degree, does it changes? The answer is no. First of all, it needs the same. All the molecules need to gain the temperature, yes or no? And where this energy is getting utilized? This energy is getting utilized to break the intermolecular forces of attractions between the molecules. Then they convert into steam. To convert into steam directly, if you maintain the temperature directly, no. Directly, that's why sudden changes doesn't happen. So ice kept in the normal temperature, suddenly it becomes into water. No, slowly it is becoming into water. The boiling water, suddenly it becomes into vapor. No, not suddenly happens. Yes, students. Why? Because they are guided by intermolecular forces of attraction. So to break these forces of attraction, they need some energy. So the amount of heat required to change a particular amount of water at 100 degrees Celsius into steam, this is called as specific heat of vaporization. We have the values also. So 2260 joules per gram or 540 calories per gram. That's why steam causes more serious burns than the water. Steam contains high temperatures, students. That's why they cause more burns than the normal hot water. So next, why? Because hot water still contains some intermolecular attractions. To break that attractions, more energy is needed. So when steam contains more energy. Latent heat of solidification. Here solidification is the opposite process, students. Opposite process means conversion of water to vapor is boiling, yes or no? Now conversion of liquid to ice, does it require energy or is it releases energy? To convert a liquid into vapor, we are providing energy. To convert water into ice, do we need to provide energy? Are we providing energy? Are we keeping the water on gas stove for ice? No. Where we are keeping? In the freezer. That means we need to cool down, yes or no? When we cool down, the temperature is utilized or released? Temperature is liberated, released. So the amount of heat energy liberated by a specific amount of water at 0 degrees Celsius, yes or no? Melting point or freezing point 0 degrees Celsius to form the particular amount of ice is called as specific heat of solidification of water. Its value is 336 joule per gram or 80 calories per gram. So it is on account of high specific latent heat of solidification that takes lakes and rivers do not freeze suddenly. Suddenly winter means suddenly freezing happens? No. And even students, even upper layer only freezes, inside water is still warm, yes or no? Lakes and all the rivers will freeze, only upper surface only. Do all the inner water also freezes? No, because of this heat only. Understood? Got the clarity? Still they contain some heat energy, right? So next, chemical properties of water. Nature. What is the nature of water? Nature means whether it is acidic or basic. Water is neutral substance, students. It is neither acidic nor basic. So pure water is neutral towards the litmus paper. So stability. Like, is it a stable molecule? Water is a stable molecule. And one more thing, there is no 100% stable molecule, students. There is no 100% stable molecule. It is stable for some temperature conditions only. But still, we can influence water. Water is reacting, right, students? Ultimately, we can influence. So, water is very stable compound. It does not decompose into elements when heated at ordinary temperatures. It doesn't happen. But when you heat at 2000 degrees Celsius, it also decomposes into hydrogen gas and oxygen gas. You can check the reaction. 2H2O gives rise to 2H2 plus O2. That means water can undergo decomposition. We can decompose water into hydrogen gas and oxygen gas by boiling? No. by 2000 degrees Celsius. Got the clarity? Right. So reaction of water with metals. These are also famous reactions. When metals react with water, they form the respective hydroxides and hydrogen gas. And in metals, if you wanted the discussion, so students, we have some highly reactive metals, some moderately reactive metals, some least reactive metals. So here we have in this slide highly reactive metals: sodium, potassium, calcium. They can even react with cold water also. Temperature is one of the main reason behind the reactions, but without temperature, cold water also these metals react, highly reactive. And what do they form? The respective hydroxides. You can check sodium in water, sodium hydroxide, and what is the gas releasing? This is main important one, hydrogen gas. And potassium in water, what is the compound producing? Potassium hydroxide. This is also common, yes or no? What is common? Hydroxides. Here sodium, so sodium hydroxide, potassium, so potassium hydroxide, so calcium, so calcium hydroxide. And the ratios are different because of the valency of the metal, right? And what is the common here? Hydrogen gases are released. And what is the nature of these hydroxides? All these are basic in nature, right? So these are highly reactive metals. If it is moderately reactive metals, aluminum, zinc and iron. In this, aluminum is more reactive than zinc, zinc is more reactive than iron. So they also don't react more vigorously, moderately react, and they do not form hydroxides, they form oxides. But one thing is common. What is that common thing? They all produces, students, they all produces hydrogen gas. See, you can check. So highly reactive metals produces hydroxides, moderately reactive metals produces oxides, and they release hydrogen gas. So aluminum, aluminum oxide, zinc, zinc oxide, iron, iron oxide, and they release hydrogen gas also. Next, reaction with magnesium. So magnesium doesn't react with cold water, students, but it reacts with hot water. Even burning magnesium can even react with steam also. Ultimately, it produces magnesium oxide and hydrogen gas is released. So one thing you have to remember, when metals react with water, what is the gas they release? Hydrogen gas they release. And what do they form? Either oxides or hydroxides, all are basic in nature, right? So here water does not react with react when treated with metals like copper, silver, lead and mercury. You have to remember, make a note about these points, students. All metals do not react with water, like gold, silver, platinum mainly. They are not reactive with water. They are unreactive with water, right? Action of water with non-metals. So students, see, when first with carbon. Carbon reacts like hot carbon when it reacts with super steam, super hot heated steam, it produces carbon monoxide and hydrogen gas. C plus H2O gives rise to CO plus H2. This reaction is very important in the industrial scale. Why? Because this combination of carbon monoxide and hydrogen gas is called as water gas. Where it is used as a fuel. Why? Because it is having one of the highest calorific value, students. Highest calorific value. It is used as a fuel for burning purpose, for the energy purpose. So one industrially very important reaction. Carbon plus H2 gives rise to carbon monoxide plus H2. That combination is called as water gas. Next, with chlorine. So water with chlorine produces hydrochloric acid and hypochlorous acid. Hydrochloric acid also has many uses, students, in the organic synthesis reactions or production of any hydrogen gas, chlorine, many other reactions we use these acids, mainly hydrochloric acid. So next, reaction of water with metallic oxides. So we all know metallic oxides are basic in nature, yes or no? When these metallic oxides, it's a sodium oxide, potassium oxide, calcium oxide, when they react with water, they form the respective hydroxides. Hydroxides are straight bases, arrhenius bases. So sodium oxide, sodium hydroxide, potassium oxide, potassium hydroxide, calcium oxide, calcium hydroxide. So every reaction has a mechanism. Also, students, how does it react? So you have to remember what is the product, what is the reactant. It depends upon the reactant, you can get the respective product. So the previous slide is about metallic oxides. Now we have non-metallic oxides. So metallic oxides are basic. What about non-metallic oxides? They are acidic in nature. Metallic oxides, when they react with water, they produce bases. Now answer, non-metallic oxides, when they react with water, what do they produce? They produce acids. And same, opposite, right? So look at the reactions here. SO2 plus H2O will get sulfurous acid, H2SO3. SO3 plus H2O will get sulfuric acid, H2SO4. NO2 plus H2 will get nitrous acid and nitric acid. phosphorus pentoxide plus water will get phosphoric acid, H3PO4. Carbon dioxide plus water will get carbonic acid. Students, all these acids, where do they form? I'll explain, listen. So industrially, they release, there is a big pipe is there, students, where the smoke is getting released. So mostly that smoke contains carbon dioxide, sulfur dioxide, nitrogen dioxide. They released into the atmosphere. These gases, they react with water vapor present in the air and they form these acids. And these acids dissolve in water, rain droplets, and they form as acid rains. These are the causes of acid rains. These are the reactions behind the acid rain formations, remember. So next, test for water. How can we test it is a water? By drinking. For testing, can you drink? So no, students, pure water is a colorless, tasteless and odorless. Pure water means only water. Pure water boils at what temperature? 100 degree. Freezes at 0 degree. At a pressure of 760 mm of mercury or 1 atmospheric pressure. The pressure at sea level. So when a drop of water is poured over anhydrous copper sulfate, which is white color, students, CuSO4, which is white in color, when water is added to it, if it is a pure water, it converts into bluish color. That means this water forms water of crystallization with copper sulfate. This is also called as blue vitriol. Based on color change also, we can identify a particular substance as water. Yes or no? All the transparent liquids are water only? No. Yes or no? Right. So uses of water, like what are the uses? Like we all know, this is a general compound. We are all using in everyday life. Yes or no? In all the life process, for drinking purpose, yes or no? For washing purpose, for all the domestic uses. Like why do we need, our body need water, students? Why? Because all the biological activities, all the digestive system need this water only for all the transportation of the minerals, everything throughout the body, right? So next, used in the agriculture. So this also, how plants can absorb nutrients from the solid soil. Can the solids can it take? No. When you add water, these solids can dissolve, these nutrients can dissolve in water and it can absorb that water present with the nutrients. Then this plant will grow. Yes or no? So irrigation purpose, for all the purpose, even for spraying insecticides, pesticides, how do we spray? By adding into the water. Yes or no? Fertilizers also, directly we apply fertilizers? No, by adding into the water only. Why? Because these fertilizers dissolve in water and this dissolved water with fertilizers will be absorbed by the roots of the plants and trees. Used in the generation of electricity, right? Have you seen the big dams? Near there is a coil of copper that is called as dynamo, where the mechanical energy is converted into electrical energy. So for the power generation also, this is also called as hydro power, students. The power which is coming out of H2O. So for electrical generation also we use water. So used in the industries, where do they use? Like what is your idea? Where do they use? For washing purpose. Yes sir, without washing can they use any industry? Is there any industry? For boiling purpose, for cooling purpose also. For example, a steel industry is there. They need to cool down that hot steel or not? How? By normal cold water. Some other oil industry, paint industry are there. They need to boil first of all the chemicals. How do they boil? With water only. So without water, there is, in general, there is no industry, students. So in all the industrial scale, water is used. Uses in the manufacturing of chemicals, right? By decomposition of water decomposition into hydrogen gas and oxygen gas. Hydrogen gas is used in the preparation of fertilizer, like ammonia, N2 plus H2, 3H2 gives rise to NH3. It is used in the preparation of hydrochloric acid also. And oxygen, liquid oxygen is used in as a fuel, and it has many uses, other uses. So for all these purposes, we use water. So what are the factors affecting shortage of water? With all these uses, we should have sufficient amount of water. But do we have sufficient amount? The answer is no. Not in your place. Think about the global level. So the reason is increasing in the population has increases the demand of water. More is the population, more is the consumption, right? If more is the consumption, reducing the levels of water. Change in the lifestyle of people has increased the consumption of water. For everything, for every purpose, every room they have a tap. Yes or no? For everything so using water is okay. We are wasting water in the name of using. Brushing the teeth, what will do? You open the tap and do that. In the tank, water is completely completely over. Then what will happen? You'll switch on the motor and you'll do some activities. What will happen? The tank will fill up, all the water is getting wasted, going down. Every house it is happening. Yes or no? for washing, even for bathing also, you simply on the tap, and the water on the in the bucket, water completely filled and simply flowing out. The water gets wasted or not? Every day we are wasting water, students. Mostly in the urban, in the cities, we are wasting a lot of water. We have water, we are wasting it. So that is not good. So these are all the reasons for the shortage of water. So urbanization, that means like growth, industrial city, has decreased the groundwater reserves, as concrete road do not allow the seepage of water. Okay, so if we have the fresh like all the trees everywhere, so what will happen? Rain will come, the rain falls down on the ground, from the ground it enters into the aquifers, underground aquifers route, right? But we are all now, everything is concrete, the big buildings are there, and the remaining space is occupied by the roads. It's a completely concrete jungle. Is there any way to pass the water to the ground? That is called a seepage of water, students. Is there any passage? No. Most of the ground in the urban areas is covered by the concrete. Understood? By the buildings, by the roads everywhere. So that's why there is no chance. That's why groundwater levels in the cities are decreased. Why? Because there is no chance. This water is entering into the drain and some going somewhere. Near this area, the level of groundwater levels are more. No. Why? Because there is no seepage only. That's why. Industrial demand for water is increasing many times. Many industries, many manufacturing units are there. So they are also using these water for all the purposes. So definitely we need to conserve water, sir. We need to save water, conservation of water. In summers, people face shortage of water because the level of groundwater goes down, and so there is no water in the wells and tubewells. Mostly in the areas which are near the desert areas, mostly in the Rajasthan, in the India, they face the shortage of water. Yes or no? Why? Less rainfall, like more usage than even in normal areas also, students. In summer times, the shortage of water we'll see. So definitely we need to conserve water. How to conserve? The best thing is rainwater harvesting. We have sufficient rains, and when it rains, what we are doing? All the rainwater is entering into the drainage system. It's going somewhere else. So we need to harvest this rain. So rainwater simply flowing down in the drains and is lost. Instead, this rainwater can be collected and is used later. How? This is called as rainwater harvesting. Rainwater from the rooftops and kitchen can be collected in the underground tanks, and from the water from these tanks percolates underground and recharge the aquifers. That means we need to construct the ground underground like a septic tank, and all this rainwater can be subjected to this underground. And all this water, when it enters into the underground, what will happen, students? Water slowly, molecule by molecule, it enters into the groundwater or not? And it enters, ultimately it enters into the ground, and slowly all the underground aquifers will be filled. So this should be adopted by everyone. So this is called as rainwater harvesting. Ultimately, we want to increase the level of undergrounds so that we can maintain that particular amount of water, which is the essential thing for our survival. Water is one of the main compound. Students, all the life is because of H2O only. So we discussed all the points clearly, all the reasons. I hope you got the clarity, students. So thank you.